Hey, welcome everyone. Jacob with Desert Creative Group, and we are here in Denver, Colorado, or outside of Denver at the Red Rocks Amphitheatre. And today we are using the Tersus MVP S2 to do a LiDAR collection or a SLAM collection of the amphitheater. So why don't you come on along on a walk with me and we will capture it and show you what the data looks like later. So at the amphitheater here, it's actually carved into the red rocks that are here natively, and the red rocks open up to the amphitheater out this way. And so as we're walking, you can see the amphitheater is a natural landscape amphitheater that allows for very good acoustics, and it's in the United States. It's a very big reward to play here. So the Tersus S2 is a SLAM-based system that incorporates both LiDAR, imagery, and then on this unit specifically, it has an RTK antenna and receiver. So we actually have a RTK fix via in-trip. So you have centimeter level precision through the GNSS. And then as we're walking, it's actually scanning and capturing data out to essentially 120 meters. And with that, photos are being captured at the same time. And so what it'll do is allow us to capture a very dense point cloud. And then when we process the data, we'll have a colorized point cloud of all of this that we can export into an LAS or a LAZ and other file types as well. On this project, we've walked about, I'd say probably for about 20 minutes or a little bit over that. So for this unit, it works great for the stability for large projects like this, where you may be going up and down in elevation. Maybe projects where you have maybe a little bit more open corridors where you need to be able to shoot farther to get points for structure to connect together for the geometry for SLAM. And so it makes it a really good use on very large projects like this. So for this system, it actually incorporates a battery system that can last up to 3 hours. So right now I'm utilizing it in a dual battery setup. Each battery will last about an hour and a half. If I get to a utilization of one whole battery during the collection, I can actually swap that battery out, hot swap it, and keep on collecting, which makes it very nice. The interface to control this is actually through a web UI. So it's just a Wi-Fi partnership to my phone. So it means I can control this from an Android device, iOS device, or even my computer. And the nice thing is I can see live as I'm actually capturing the data and see what I've actually captured, and check the density, make sure I'm not missing anything as I'm capturing. So, you know, as I'm walking, I just have my phone in my pocket. If I need to check on something, I can take it out. Otherwise, it just makes it easy so that I can still pay attention to what's around me as I'm walking and capture data effortlessly. So this system, different than other systems, does have a very robust SLAM algorithm. So one of the things that it does is it really helps with drift, especially when you incorporate the RTK. So especially on a project like this that's outside, we have GNSS fix. That allows us to actually capture data very quickly and effortlessly without really, running into some of the similar issues that you would get with traditional SLAM systems. Also on the processing side of things, as we're walking around, there's been people, walking past and things like that. The processing software does have ability to reduce noise, but also help remove some movement from people and things as such. So that is one of the big benefits with this system, is the robust processing, the SLAM algorithms, and just the ease of collection. So with this system, we can actually capture very accurate data because of the GNSS and RTK system that's built into it. And one of the things that, that really benefits is localization of the point clouds. So once we bring this data back and we process the data, if we were to want to extract points out, we could also come out and locate those points again, utilizing an RTK system, and we could be within centimeter level precision, locating those points back again. That's one of the beauties of this system, is just how accurate it actually is. So with SLAM technology, I feel like this is one of the big advancements of our day. It's really going to help improve and make data collection very much more efficient, just because of how quickly and accurately we can capture data to the centimeter level precision without having to, just stand and observe in one spot, right? Like we can capture, 600,000 points a second with this system. So when you look at that, we can capture very robust and large data sets very quickly. But the beauty is we have that data, we can extract out what we need, and that data can always be recalled upon for historical documentation, for managing project sites, whatever it might be. You always have that data readily available for any needs on a project site.